Okay, good afternoon, students.
Good afternoon, sir.
Yeah, we will start after a while. Let others join. Shall we start?
Yes, sir.
Okay,
Yes, sir.
fine. Okay, let us revise whatever we have studied till date. So we are concentrating on the rigid body mechanics. And whenever we talk in terms of mechanics, what we see as per the definition of mechanics, it is nothing but that study which deals with the motion of a rigid body whenever it is acted upon by some force. So we come across two terms. One is of rigid body, and mechanics, it is nothing but the study related to the rigid body's motion. And what compels any rigid body for motion? It is nothing but the force. We saw the force are of two types. I mean, one force is responsible for causing translation, and another which cause rotation. Translation means the effect of the force on the rigid body will cause that rigid body to move in one line, either this or inclined. But that line is maintained. Rotation is something which twists, right? So we saw when the force is acted on the rigid body, it will, if it is causing rotation, then that force, associated force causing rotation, is known as moment. For translation, we have seen the example of concentrated loads. How these concentrated loads are? They are represented with the help of arrow. So a concentrated load may be like this, or like this. Moment, it may be like this, or it may be like this. That means we have considered anti-clockwise to be negative and this clockwise rotation or moment to be positive. So these are few sign conventions which we have followed for moment. For concentrated loads or concentrated forces, what we have considered, this to be negative and this to be positive. This is negative and this will be positive, something of this sort. So we have also assigned some sign convention for the concentrated forces. Okay. So concentrated loads or force. Okay. We have also, if you remember, I have told you that how these concentrated loads are actually. Whenever the load which is connected to an area which is very, very large compared to the connection point of that load. Like for example, if you take an example of a roof or slab, and that roof or slab is connecting a fan like this. isn't it? So this point of contact compared to this complete area may be treated as a concentrated load area, isn't it? Similarly, if you take an example of a vehicle which is standing on road surface is an infinite surface. Whatever loads those are coming from the axle of this vehicle, those will be treated as concentrated load. So whatever forces we have seen, those are of this these types. And there are some external forces which compel the rigid body to move in one line. So we can also assume that force to be concentrated force, right? So if you apply some kind of push to this vehicle with the help of your hand, so you can treat your hand surface contact and the surface of this vehicle. In comparison to the surface of this vehicle, the contact area of your hand is less. Therefore, whatever force you are applying, that can be treated as concentrated force. Also, if there is a rope which is connecting this vehicle, and if you are trying to pull this rope, again the same force, right? So such kind of force, those are available, and those are responsible for the motion of this rigid body. Rigid body in the sense the body which on which we apply force, and that force is not causing any significant change in the shape or the size of the body, then that body is known as rigid body, right? So we have seen up to this, we have solved numericals associated to translation. We also saw few examples related to moment. Now, forces may be, as I have already discussed, they may act randomly. And in case of a concentrated force like this, which is inclined in nature, we saw that if we want to take moment about any point by the virtue of this force, let's say F, and about this point, random point O, then what we did, we have calculated the distance which is responsible for causing the moment. And as per the definition of moment, about any point, let's say O, because of the force F, it says that it is nothing but the product of force and the distance. Now this distance is very important. This distance is nothing but perpendicular distance from the point, this is known as the moment center, and the point and the line of application of the force. So that perpendicular distance has to be identified. In order to identify that perpendicular distance, what we did, we extended the line of action of the force and we dropped the perpendicular. Depending on this geometry, then we have found out the associated value of moment, right? So this was the case wherein only one force was available with us. But in actual practice, you will find that there are a number of forces, those may be acting on a rigid body and in any damn direction. So based on that, how to evaluate the moment, that we will now see. So one of the methods is to drop a perpendicular from the moment center, and this D is known as lever arm, or rather moment arm. This is known as moment arm, and this is known as moment center. Okay. So these are a few terminologies which you need to remember. So now we will try to extend this phenomenon, and let us try to see, is there any other way to express this or not. So let us try to explore that. For that, let me consider this axis x and y, and let me consider a random force which is acting at some location over here, and the nature. Yes, yes, any problem? Hello,
No, sir.
should I continue?
Yes, sir.
Yes, sir.
Okay, so fine. So let me consider that there is a force which is inclined like this. Let me consider the magnitude of this force to be capital F. Let this angle be theta with respect to x-axis. And let me say that this is the point O, about which we are supposed to identify the moment which will be caused by this force F. Let me assume the distance from O to, let's say, point A, that is this point A. Let this be small x. ठीक है, यहाँ से यहाँ तक का जो distance है, this is small x. Okay, right. Now you will appreciate one thing. I am representing this inclined force in this manner. Please let me know whether this step is right or wrong. Okay, so what I have done, I am assuming the same point O, and at this point A, which is at a distance of x from O, I am representing this inclined force in this manner. Is this okay?
Yes, sir.
Okay,
Yes,
what I
sir.
have done, I have resolved this inclined force into components. And if I am saying that resolution is there, so fx can be f cos theta, fy can be f sin theta. ठीक है? Is this okay?
Yes, sir.
ठीक है, right. Now see, if these two things are equal, whatever equations this left hand side figure will yield, those equations will be true for this. Don't you agree? Yes. So what I will do, first of all, I will try to identify the moment which will be developed by the virtue of this force F using this figure itself. So what I will do in order to find out moment for left hand side, this is LHS, this is RHS. What I will do, I will extend the line of action of force. Do you agree?
Yes, sir.
And after drawing the line of action of force, what I will do, I will drop the perpendicular from this point like this. Let me consider this small distance or perpendicular distance to be d, which we call it as the moment arm. So what I am doing is to find out the moment about point O due to F. I am simply making use of this equation, F into d. What is the value of d from this geometry? Can anyone tell me? It will be in terms of x and theta. So can you please tell me what will be the value of d in terms of x and theta? Yes. D in terms of x and theta. क्या होगा?
X sin
X
theta.
sin theta.
Exactly. It will be x
Sin theta.
sin theta. Correct. है ना? So finally, what I can say, moment about O due to F is F. अभी मैं इसको क्रॉस नहीं करता हूँ because this is X. This may get, you may be confused. So this is point that is into X sine theta, like this. Correct? So let me
Yes, sir.
call this as
Yes, sir.
equation 1. Now I will go to this right hand side. On this right hand side, if I am saying that these two are equal, right? So let us try to identify with the help of the moment equation, whatever we have, that is force into the perpendicular distance. If I apply the same to this, whether I am getting the same equation or not, that's what we are supposed to identify. So let us try to find out. So now see, if I consider this right hand side, there are two forces. Okay, one is acting in the x direction, another is in y direction. So I will have to consider or find out two moment values because there are two forces. So moment about point O due to, let's say, force in x direction. What is the equation? F x into d. Okay, this is the general equation. What is the value of d over here? I am assuming fx force. What is the value of d?
Sir, X.
See, again I am repeating, d is the perpendicular distance. Okay. Now tell me, what should be the value of d?
Sir, 0.
Exactly, it will be 0. Okay, because in order to visualize that, what you do, you extend the line of action of this force. And I am extending this. I will use color. I am extending this line of action of force of Fx. How it is this? How is the line of action of this force? It is passing through the point O. That means it is passing through moment center. There is no perpendicular distance, isn't it? So for such case, whenever the line of action of the force is passing through the moment center, I am repeating, line of action of the force, if it is passing through the moment center, there is no perpendicular distance. Therefore, the value of this d shall be 0. Very correct. And ultimately, what value will you get for moment about point O because of fx?
0.
0.
0. Got it? So remember this thing. Whenever the line of action of the force is passing through the moment center, perpendicular distance is 0. Now let us check for another force because there are two forces, those are involved on the right hand side. Therefore, moment about O due to Fy into D. Correct? Abhi batao. Now for this case, what is the value of Fy? Fy
F
is nothing
sine
but
theta.
F sine theta. I will substitute that value F sine theta. And now can you please let me know what should be this D value?
X.
Yes, it will be X. Now see, why? Because if you see the uh, distance from the moment center to the line of action of this force Fy, you will see this X is making a perpendicular distance to the line of action of that force. And therefore, this will be X. Or in other term, am I right? So moment about this thing. Correct? Have you understood this? Have you understood this?
No, it is not visible.
हाँ, अभी देखो, ये तो मैग्नीट्यूड हमने आइडेंटिफाई किया. What about the direction? So let me consider left hand side. In which direction this is rotating? About 0.0.
Anti-clockwise.
Anti-clockwise. So therefore this will be negative. Correct? So equation 1 will be minus f into x sin theta. बराबर है? If I come on this side, what do you observe? Moment about 0.0 due to fx, that is 0. Moment about 0.0 due to fy, it is acting in this manner. And how this line of action of force will rotate about this 0.0, whether clockwise or anti-clockwise?
So
Anti-clockwise.
anti-clockwise.
Again anti-clockwise, so minus. So from equation 1 and 2, what do you observe? एक मिनट, equation ये 3, ये 2. 1 and 3, what do you observe? एक सिमिलरिटी हम ड्रॉ कर सकते हैं कि ये जो कंपोनेंट है, right? But over here, what do you observe? This is capital F, that is the final force. However, over here, it is nothing but the component of that force. It is not capital F. Okay, so right now I cannot compare these two things. But if I add these two terms, what do I observe? Moment about that point O due to Fx plus moment about that same point O due to Fy. What is the final value? 0 plus minus F into x sine theta. Do you agree?
Yes, sir.
Or finally, what I can say? Sum of these two is equal to minus F into x sine theta. Let me call this equation 4. Now, from equation 1 and 4, what I can say? बराबर है?
Yes, sir.
ठीक है? So this was identified by Varignon, Dr. Varignon, and based on that, based on his observation, the principle associated to this is known as Varignon's principle. Sorry. Varignon's principle. ठीक है? So if I want to express this Varignon's principle in words, how it can be done? It is stated that moment about any point due to certain force is nothing but equal to moment sum of the components of the force about the same point. ठीक है? So you can note down this. Varignon's principle states that moment of a force about any point is equal to moment sum of its components about the same point. So this is nothing but moment sum of the components of force about the same point, ठीक है, यानी जो मोमेंट सेंटर रहेगा वो सेम रहेगा for these components, but the thing would be it will be the addition of these two components. Moment sum addition, moment sum. It will be the moment sum of these two components. Components are fx and fy. Okay, this is what we are talking about two-dimensional force, wherein you will see fx and fy value only. There is no third term, that is fz. Right? We are only discussing, concentrating on two-dimensional force system right now. Okay. Is this understood? This is the Varignon's principle, and this Varignon's principle shall be applicable throughout this course as well as your higher semesters also. In RCC, that is reinforced concrete structure course, you will see the application of this whenever you will be analyzing and designing the foundation. At that point of time, you will have to make use of this Varignon's principle. Is this clear? Is this
Yes, sir.
explanation okay? Okay? So I will move ahead and let us try to apply this Varignon's principle, and let's see how the numerical associated to this principle can be solved. Let's see. Okay. We will take a few examples. Such type of examples are commonly asked in your examination. So, okay, exam point of view, it is okay, but what I think is you should practice the numerical by going through the different reference books or textbooks whichever I have told you. You practice more and more numerical so that in the coming future you will be in a position to solve the associated problems which you will be coming across. And these numericals you will find to be very much interesting because you will be dealing with design problems. Designing in the sense you will be in a position to, decide the dimensions of different parts of a structure. So, for example, if you see any building, a residential building or commercial building, which is made up of RCC or steel, whatever it may be, if you are in position to decide that what will be the dimensions of the beam, column, what will be the dimensions of slab or roof, then that part, whatever I am saying, this is the part of design. If you are in a position to decide this, then it will be very much useful for you people, because this is a part of civil engineering degree course. Okay, designing, right? Before designing, we should be in a position to analyze things. Analysis का मतलब होता है identifying the forces which are required to decide the dimensions of such kind of structures. So before designing, you should know how to analyze a structure. Whatever we are discussing right now, it is related to the analysis process. So once you are very much expert type of in analysis, then it is a matter of practice numerical to design a structure. Okay, so let us see how you can apply that Varignon's principle and also other knowledge to solve this problem. So this is a grid type of structure, whatever I am drawing. So this may not be straight. And 6. These are straight lines, you can assume, although they don't look like. Then again 1, 2, 3, 4, 5, 6. One minute. Hold on. This will be very small. One, two, three, four, 5, 6. Okay. So this is a grid. You can consider this to be your graph paper. Okay. Right. Dimensions of this grid is 1 meter by 1 meter. 1 meter by 1 meter. Okay. This straight line like this. 1 meter by 1 meter. Okay. There are few forces which are, acting on this. So the position of first force, it is starting from here, from this point to this point, like this. Then second is this point, and it is acting up to this point, like this. Okay. What you are supposed to do, you are supposed to identify the moment which will be caused by this force and this force whose magnitude is capital F, capital P, about these points. Point A, then this is point C, this is point B, this is point D. Okay. So this problem statement, it consists of few more things. Capital F is given as 450 Newton. Capital P value is given as 361 Newton. What you are supposed to identify? You are supposed to identify the moment of these two forces about points A, B, C, and D. About points A, B, C, and D. Okay? That is moment because of force F about points A, B, C, and D. Okay. or this is what you are supposed to identify. Similarly, you are supposed to identify moment because of P about, understood? This is what is asked. So let's go step by step and let us try to first of all identify moment about point A because of force F, right? So now you can see you can make use of the earlier technique, that is by extending the line of action of the force and then dropping the perpendicular. Okay, either you can make use of this or you can use Varignon's principle. What does Varignon's principle suggests? Moment about any point due to force is nothing but equal to moment sum of the components of the force about that same point. Okay, so let me consider this to be equation 1. Now let us try to identify the right hand side. Okay, since we cannot directly calculate this, we have the information of the force which is inclined in this manner, that is the components, right? To identify the moment about point A because of Fx and moment about that same point due to Fy, let us try to separate this figure and identify what will be the Fx and Fy value. So I will separate this out for your understanding purpose. Later on, you will come to know how to calculate the other values. So from this figure, it is like this. Okay, this is capital F, whose magnitude is 450 Newton. Am I right? This distance is 1 meter. Do you agree? And this is that point A about which we will be taking the moment. Am I right?
Yes, sir.
What is this distance from A to this point? For that, you can count these blocks or the distance of this block 1, 2, 3, 4, and 5. And each block is of 1 meter by 1 meter dimension. So, what according to you will be this value?
5 meter.
5 meter. And similarly, can you tell me what will be this much distance?
3 meter.
3 meter. Correct? Now, what you do, since this is an inclined force, you will have to identify this theta value, and based on that, you can then identify the Fx and Fy values. So, can you please let me know what is this value of theta from this geometry? Yes. How much will be the theta value? Tan inverse of, let's say, this distance divided by this. How much will be this distance? Yes. What will be this much distance?
4.
I
So
think
4 meter.
4 meters.
4 meter. Correct.
Yes,
And
sir.
what about this? 3 meter. So 3 by 4. Is this okay?
Yes, sir.
Okay. So you can see what I have done. I have evaluated. This will be 4 meter and this will be 3 meter. Based on this geometry, then I have evaluated the theta value. How much does this come out to be? Theta? Radian में होगा. Yes, theta value कितनी है? Is it 36.67?
Yes, sir.
Right? Okay, 36.67. So what will be the value of fx? F cos theta. ठीक है? F value कितनी है? 450. Cos of 36.67. Is this 67 or 87? 36.67 or 87 कितना है?
So 36.86.
8-7.
87, no? Fine. So do that correction. Substitute this value, and what will be the final value of fx? Is it 360 Newton?
Sir, 359.9.
Okay, 359 point something. So I will consider it to be 360 Newton. Similarly, what is the Fy value?
So F sin theta.
Yes, F sine theta. So you substitute the proper value and find out. F is 450, theta is 36.87. Substitute those values and find out what is the Fy value.
So 270 Newton.
270 Newton. Okay. Right now, I will not discuss about the directions. I have also only calculated the magnitudes of Fx and Fy. We will speak in terms of direction when we will be evaluating the moment. Okay. So, in order to calculate the moment, which will be about point A due to Fx. वो पहले हम calculate करते हैं. Let me say moment about point A due to Fx. Yes. Moment about this point A due to Fx. Fx into, let's say D. D is what? The perpendicular distance between the line of action of the force and the moment center. कितना distance है वो? Can anyone tell? So what I will do, I will extend the line of action of this force like this, and I will be dropping a perpendicular from the moment center, or the point from which we are supposed to take the moment. So what is that point? A. So I will drop a perpendicular from point A to the line of action of this force. So please let me know what is the perpendicular distance.
3.
3 meter.
Meter.
So Fx we have found out to be 360 into 3. Now let me know about this point A. Fx is causing which type of rotation, whether positive or negative, or clockwise or anti-clockwise. How it will be
Anti-clockwise.
rotating about this point? Yes, it will be anti-clockwise. So you can consider this situation. This is that point A, and the force is getting applied in this manner. So how this will rotate? It will be anti-clockwise. So minus. How much is this value? Minus 1080 Newton meter. Correct?
Yes, sir.
Yes, sir.
Next moment because of Fy about same point A. Fy into again this D perpendicular distance. तो ये देखो ये है Fy
So
and
0.
I am taking moment about this point A. Correct? What I will do? I will extend the line of action of this force. I will be dropping
1.
perpendicular from moment center on this line of action of force. How much is this value?
So 1.
1
1
meter.
meter.
Okay. So 270 into 1. And in what way this is going to rotate about that point A?
So anti-clockwise.
Exactly.
Anti-clockwise.
Anti-clockwise. Very good. Minus 270 Newton meter. Finally, these two values you substitute in this equation 1 and find out the final value.
One three five zero.
1350 न्यूटन मीटर. ये न्यूटन मीटर लिखना नहीं भूलना है, ठीक है? Since it is a moment. Got it? Understood?
Yes, sir.
Good. Now, can you evaluate moment about point, let's say C, because of F? For time being, let me consider point C, or we will go about, let's say, about point B. देखते हैं. About point B. Moment about point B due to F. तो इतना जो portion है, that I will draw. Just for your understanding, I will let you know what is the other method to simplify this. Right. So it is something of this sort. Okay. This is that point B. This is force F. This is the point of application of force. Correct. Can you please let me know what will be this much distance? So count it. Count this
4
block.
meter.
1, 2, 3, 4. बराबर है 4 meter. Similarly, count these
3 meter.
3 meter and this much
6 meter.
6 meter. That means remaining is 3 meter. This is 3 meter. Although it is not looking, but ठीक है. Okay. Correct. So in order to find out moment about point B due to F, apply Varignon's principle. Affects same point B, Fi, moment sum, right? Let me consider equation 2. I will go step by step, and what I will do, I will resolve this into components. This will be Fx, Fy. This is theta. Theta will be same value. Do you agree? Because this is 3 meter and this is 4 meter. This won't change.
Yes, sir.
Theta will be 36.87. Whatever you have found out. Barabar. Now, what you do? Moment about point B due to Fx. You identify this value. What has to be done? You are supposed to extend the line of action of the force and you are supposed to drop a perpendicular from this moment center to the line of action of the force. That will give you the small d value. How much is this value in this case? Fx into d. Kitni value hai d ki?
3.
3 meter.
3.
Okay. So Fx is 450 cos of 36.87 into 3. Correct? How is this rotating about point B?
So clockwise.
Clockwise. So this will be positive. Later on, you can find out the final value. Then moment about the same point B because of Fy. It is Fy into D. For this D, that means associated to Fy. What will be the D value? If you are taking moment about point B, I will extend the line of action of this force and I will drop a perpendicular from this point to this line of action of the force. How much is this value?
4 meter.
4 meter. Okay. And substitute sine 36.87 into 4. And how is the nature of the rotation because of Fy? It is again clockwise. So both these values are positive. You find out the final values, add them up, and you will get the moment about point B due to F. Simple. So in the similar manner, in the similar fashion, what you are supposed to do? You are supposed to identify moment about point C and D because of F, and one more thing is there, force, one more force is given. So considering the same thing, you can calculate the moment because of P about these points. So can you do that? You must have understood this explanation. I hope so. Okay. And based on this explanation, you can solve the other part. Can you do that?
Yes, sir.
So take this as an assignment. If you find any kind of difficulty, we can discuss in the next class. So is this okay?
Yes, sir.
Yes, sir.
Okay. So I will stop here. Thank you very much.
Thank you, sir.
Thank you, sir.